So special pair of angles. Our first special pair is it starts with C. Anybody want to guess what they might be?
Oh.
How about congruent? Okay, actually, that is a okay. How about when the two angles measure add up to 90? What's that called? CO.
I don't remember.
Yeah, it's COM. Complementary. Almost. That's okay. What's important is that you know it after this, right? That doesn't matter. So sometimes we abbreviate them this way, with little angle symbol with S in them, right? Because we're talking about more than one angle. So complementary angles, as I said before, are two angles whose measure have sum of 90. Okay. Yeah, write it once. This is a definition right here. And a little bit more of that. Each angle is called a complement of each other, of the other. Okay. So each angle is called the complement of the other. So write this down. I'll wait. And here's actually a picture. You don't have to draw this picture, but here's some examples. As you can see, these two angles, R and T, they're a complementary angle because they add up to 90. These two angles are complementary angles because they add up to 90. Okay. So I'll wait. Go ahead and write it down. Next, by the way, if two angles looks like they add up to 90, can you assume that they're complementary? No. So for example, if you have two angles, they sort of look like they're 90 degrees if you add them together. You cannot assume that they're complementary, right? What do I have to tell you? I have to either tell you that they are what? Yeah. Okay. If they're right next to each other, right? If I put so I have to either tell you that they are complementary, or I could tell you that they're angle measure, right? Like for example here, if I told you that these two angles are 60 and 30, then you could say they're complementary. Or I could just tell you, okay, even if I don't say these, even if I don't tell you the angle measure, if I say angle R and T are complementary, then you know they add up to 90, right? If I don't tell you, you can't assume, right? Does that make sense? All right. So does anybody know what we call the angles whose measures have the sum of 180 degrees? Oh, okay. How about who haven't I called? I haven't called a bunch of people. Okay, how about Tony?
Supplementary.
You got it. Supplementary angles. Here's a picture for it. Oh, sorry. Let me please. Here. Okay. And again, as you expected, two angles do not have to be right next to each other like this, right? Or they could, but they don't have to be. And as you can see, this one's 50 degrees, angle A. Measurement angle B is 130, so of course they're supplementary. Or here, if this is X, the other supplement of the X is 180 minus X, right? So each angle is called a supplement of the other also, just like before. So I'll wait for you to write. Okay, so supplementary angles are these. Again, just because two angles looks like they add up to 180, can you assume that they're supplementary? No, I have to tell you either that they're supplementary or I have to tell you the angle measure of each angle, right? Does that make sense? You can't just assume. Does that make sense? All right, next two pairs of angles that are special starts with V. Anybody want to guess what that angle might be? Yeah. How about Esther? Mm-hmm. Vertical angles is correct. Very good. So let's move on to vertical angles. Here you are. Vertical angles. Again, we could abbreviate them like that. Okay. Are two angles such that the definition may seem sort of weird, but take a look at it carefully here. It says it kind of makes sense. Are two angles such that the sides of one angle, okay, are the opposite rays of the other side of the other angle. In other words, look at angle 1. You see my two sides right here, two rays? What's the opposite ray of this one right here? One that goes the other way, right? What's the opposite ray of this side right here? Therefore, angle 1 and angle 3 are the vertical angles. So as angle 2 and 4, right? So are angle 2 and 4, I mean. So this is the side of these two, so opposite ray of those two sides are right there. So it says angle 1 and 3 are the vertical angles, 2 and 4 are vertical angles. So, okay, so that's how we define them this way. And you may say, why do they define it this way? why can't they say these are the angles that are on the other side? Because if you say something like that, you may get different picture than that. Yeah? Question? Oh, okay.
Retry it.
You don't have to. But yeah, you should draw this once at least. Okay. So one thing to note, it says when the two lines intersect, how many pairs of vertical angles do you get, guys? 2, correct? As you can see, when the two lines intersect, okay, you get 2 pairs of vertical angles. Okay, as you can see in here. Any questions? What's interesting is this definition doesn't say anything about the fact that, what do you guys know about the vertical angles? They are? Yeah. Congruent. You guys remember? You learned this in intro or something? Does the definition say anything about that the vertical angles are congruent? No, it doesn't. All it says is it describes what they are. It doesn't say anything about that the vertical angles being congruent. But we know they are, right? Guess what's going to tell us that the vertical angles are congruent? Anybody want to take a wild guess here? Just like yesterday, the definition may not say this, but yeah, Yechan? The definition does not tell us that the vertical angles are congruent, but guess what's going to tell us? Because that's what we're going to talk about next. What's going to tell us that the vertical angles are congruent? Yeah. No, I just told you the definition doesn't tell you that they're congruent. But guess what's going to tell us? No. What do you remember when we talked about Yechan, like midpoints, right? The definition just told us those two segments are congruent. It doesn't say, it didn't tell us that it is half of the other. What told us that? Yeah, guess what? For vertical angles, the theorem's gonna tell us what? That the vertical angles are congruent. And this doesn't need a name because the theorem is really short. Watch this theorem. I think you're gonna like this one. Simply, vertical angles are congruent. So write it down. Okay. And we're gonna, of course, prove this, okay? So, in this theorem is interesting because you know all the other theorems, they were written in conditional, as a conditional, right? This is not written as a conditional, right? So how do I know which part is given if they ask you to prove this, and which part is the part that we have to prove? 1, 2, 3, 4. What I'm trying to say is, you know how we had conditionals before for the other theorems? So we knew which part was the given part, if you're going to prove this, and which part we had to prove. This one is not a conditional, right? This statement. So how do you know which part of this statement is given and which part is the part we have to prove? Nicholas, what do you think the given part is?
The given part is that the two angles are vertical.
That's right. 2 angles are vertical.
And what we're supposed to prove is that the two angles are congruent.
Exactly right. Very good. So,
Should you write it down?
yeah, I think this is good, and we're going to prove this. So here's a picture for it. Actually, you don't have to write the proof, but I just want you to understand from this theorem, given part is this, and the part that we want to prove. And nice, they gave us a nice picture that we could refer to, so that's kind of nice. So this is in your book. I want you to mainly really follow through and understand what the proof is saying. You don't have to write it, no. But at least write down the theorem though, and write down the given and proof part. Right? From this theorem, that's the part that's given to us, that angle 1 and 2 are vertical angles, and then we have to show that angle 1 and 2 are congruent. That's the part we need to prove. Okay, let's prove this theorem. Like I said, this is one of the nice theorems. It's really short. Okay, so if that's given, angle 1 and 2 are vertical angles, does that really help us? I'm sorry? What is typo? Oh, it is a typo. Very good. There should be an angle there. You're right. The book made a typo. Yeah, I didn't see that. Yeah. There should be an angle sign where the proof part is. Anyway, so can I start with this given? Actually, I can prove this really well. Look, I could do this. Given that angle 1 and 2 are vertical angles, step 2, I could say, oh, vertical angles are congruent. I'm done. Could I do that? No, that's the theorem that we're trying to prove. Okay, you cannot use the theorem that you're trying to prove the theorem. You know what I mean? It's good. Okay, so you can't do that. Okay, so it turns out this is one of those cases where I told you 90% of the time you start with the given. This time, if you start with given, it doesn't really help you much. So this time, you're not going to start with given. So Anybody have any idea what to? Oh, you have an idea. What do you think, sir? John? I mean, not Young. What do you think?
Angle 3 and angle 2 are
Angle 2 and angle 3 are supplementary angle. Actually, that's actually a nice way. But turns out you can't say that yet because what would your reason be if you said that? Definition of supplementary angles, right? Turns out we can't do that because I haven't told you what that they're supplementary. But I mean, I kind of see what you mean. I mean, it's so obvious by looking at it. They're supplementary, aren't they? So it's sort of interesting. Actually, they do start with this statement. So our first statement they start with is this: angle measurement of angle 1 plus measurement angle 3 equals to 180. Would you agree? Yeah, we could assume, remember, if you have a line, we could assume that lines are lines, okay? It's not sort of a line that kind of curves at the end. You know what I mean? You could assume that once you see a line, it's a line. What will be the reason for this then? Okay, a lot of you have your hand up. Let me tell you one thing. It's not because of definition of supplementary angles. Okay, you still have your, very good. Why can I not use definition of supplementary angles for this? Because didn't we say if the two angles are supplementary angles are two angles that sums up to be 180? That's what I have here, right? Why can I not use definition of supplementary angle? Because this is what a lot of people might put. Can somebody tell us why not? Go ahead. I want you to discuss with your group. Go ahead. I'll give you some time. Why not? Why can't we? Because it's not. Raise your hand if you think you know why we can use definition of supplementary. Grace? Yeah, I haven't told you that angle 1 and 3 are what? Supplementary angles, have I? Have I told you any like measurement of angle 1 and 3? Have I told you anything about angle 1 and 3 are supplementary? No. I mean, in our head, of course, it seems so obvious, right? Even though it may be obvious to you, can you just state that, right? Something that's obvious as that, right? Just because they look like they're, I mean, we know that they're supplementary, but we can't say that because we have it's not given. So then, what would be the? Do you see why? Right? I haven't told you that they're supplementary. I haven't told you anything about measurement of angle 1 and 3. But then, what allows us to say this then? Let's see if people remember. A lot of you had. This is actually back in I think like first week or so. This is the one with where, who remember? Let's say postulate. Let's say postulate. It's not any theorem. Say postulate. Okay, a lot of you still have your hand up. Eric, what do you think, sir?
Angle addition postulate.
Angle addition postulate. Really?
Yeah.
Wait. Isn't angle addition postulate just you add two angles together? Is sum of the whole thing?
Yeah.
Is that those two angles are sum of the whole thing?
Yeah. Well,
Go back to your postulate. Go ahead. Go back to your postulate. I'll go back. Okay, hold on.
Wait, Mr. Wong.
Okay, here we go. Look, guys. Here, doesn't it say this? If B is interior of this angle, okay, this angle plus this angle measure is the whole angle measure? How? But you guys are right. It is the angle addition postulate. But why? It doesn't look like it though. But why? Raise your hand if you think you know. Let's see who remembers. Two people. How about Tony?
The special case.
Yeah. Remember I told you this has two cases.
You didn't show us the bottom.
Well, I just wanted to see if you remember. Okay, remember angle addition postulate has two parts, right? It has the regular case where, and then here's a special case where if you happen to have a straight angle, right? What do we know? And B is not on this line, then angle AOB plus angle BOC is what? 180. Does that make sense? You guys, oh yeah, you weren't here. Okay, does this make sense? Does that make sense? So please remember that the angle addition postulate has two parts. Okay, and reason for that reason. Let me go back to that one. Hold on. So the correct reason for statement 1 is because of the angle addition postulate. Again, why can we not use definition of supplementary angle, Austin?
Because you didn't give us the measures.
Yeah, I didn't give you the measure, or I haven't said that there are supplementary angles. If I did tell you that they are supplementary, then yes, you could use this, right? Then you could say, oh, if angle 1 and 3 are supplementary, then of course 1 plus 3 is 180. But I haven't told you this. So if you just have to say this from here, from this picture only thing you could say here is because of the angle addition postulate. If I were you, I would write down the second part, right? Just to kind of remind you, right? Because when we talk about angle addition postulate, people only think about that first case, right? Remember the second case when the angle has to be a straight angle. Question?
We don't have to write this.
Yeah, no, but yeah, this is in the book, but I just want you to follow along. But you might want to probably take a note here. Put a note saying, right, this is the angle addition postulate, second part. All right then, what can we do next? Eamon, any idea? So from here, we want to get to angle 1 congruent to angle 2. Since 1 and 2 are vertical angles, they're congruent. That's sort of correct, but that's what we're trying to prove. That's what we're trying to prove. So you can't use the theorem that you're trying to prove as a reason. You know what I mean? Because if you could do that, then all the proving theorems would be really easy. You just use that theorem that you're trying to prove. Does that make sense? So what can we do here? Don't we want to say something about angle 1 and 2 congruent? How can we do this here? Oh, a lot of you. How about point 1? What do you think?
Angle 1 plus angle 2 equals.
Angle 1 plus angle 2 equals to what? Oh, okay. What can we say here at this point? Naomi. Right. Eamon, did you hear what she said? No? Can you say that again so Eamon could hear? Did you hear what she said? She said this, Eamon. Eamon, what's the reason that we could say this as a second step? Do you see it? What would be the reason for this? Substitution is correct. How is it substitution? Can you tell me how we can substitute this? What do I substitute for what? Here, in place of 180, what do I substitute? Oh, yeah, here. So I have measure angle 1 plus angle 3 here, right? So let's say I'm starting with this one. In place of 180 right here, I'm plugging in measure angle 2 plus angle 3 on this place. Everybody okay with that? Does that make sense? Question, sir? Oh, you know what to do next? Okay, a lot of you know. Okay, good. Yeah, at this point, you're like, oh, that's really easy. Now, all we have to do is, I have angle 1 right here. I have angle 2 right here. Look, it's adding the same number to both sides. That's easy. What can we do next? Yes, one person. How about Samantha? I can subtract both sides by measure angle 3 and might be done. But what would be, you're right, but what would be sort of nice to put that? Yeah, they put that in there. Remember, like, and what's the reason? Yeah, they just want you to make sure that you understand what you're doing. We are going to subtract the same amount from both sides, right? So they're saying, oh, remember measure angle 3 is, of course, equal to measure angle 3. We're going to subtract that amount from both sides. You see how it flows really nicely. Then, of course, you're going to subtract both sides by measure angle 3, then you're done. But, yeah, question?
So every time we subtract by the same number.
Yeah, it'd be nice, exactly. Every time you're going to subtract or add both sides by the same number, have you noticed that? Yeah. Can you do that? That'd be nice. Okay? Yes, sir?
Isn't it a reflexive property of quality?
Oh, yeah, I forgot to put that. You're right. So, yes. Because who could explain the point of this third step? Why would I even want to add this here? Who would like to explain to Iveta here? How about Kevin? I'm sorry?
It's like explain every step.
Yeah, it's sort of explaining every step. Anybody want to add something more to that? No? You sure? How about Yechan?
To show that they're equal, so like you're taking same amount.
Right. When you apply subtraction property of equality, you're subtracting same amount from both. I know it is really obvious. I understand. But as you read this, do you see how if I say this, it kind of tells you which one you're going to be subtracting from both sides by? Does that make sense? That's why they put in there. I know that it seems so obvious, but that's why they're putting that. Okay. Does that make sense? Okay. Now I have a question. If they were really being careful, and if I were you, if you're doing this as a homework or a test, do you think I should write fifth step and don't write these two statements at the same line? Yeah, you should write this as a fifth step because this says measure of angle 1 is equal to measure of angle 2, right? Then how do I go from measure of angle 1 equal to measure of angle 2 to angle 1 congruent to angle 2? What is the reason? And you should write that as your fifth step. Tony?
Definition of congruence.
That's right. By definition of congruence, you could go from this statement to here. Does that make sense? So if I were you, I would do that. They didn't. Okay. Yeah, please do that on the test. Because it, you know, how do you go from measure to the congruence here? You know? Yes.
Do you have to put step 3 like every time we add?
Yes, please do put step 3. Please do. Any other question? I said that already, right? Do you understand this theorem? Guys, the important thing is look at the first step. You cannot use definition of supplementary angle here. That'd be wrong. Okay. All right. And yes. Yeah, hold on. Okay, sure. Example 2 says then this is not a proof, but take a look at this.
That's right.
It's in the book. No, but I want you to actually show the work in terms of it says in this diagram. Look at angle 4 and 5. They're congruent, right? If they're congruent, they want you to name 2 other angles that are congruent to angle 5. Okay, but I know that a lot of you didn't know the answer. But write it down. How would you explain this? Using some of these, using deductive reasoning, not just because of course it's obvious. Using deductive reasoning, why do you think these 2 other angles are congruent to angle 5? I'll give you time. Go ahead. Think about it. I'll give you time. I'll wait. No, not a proof. I just want you to explain. Using deductive reasoning, why should they? Who could tell us? Give me one of the angles that is congruent to angle 5. This should be pretty straightforward, especially since we went over that theorem, right? Vertical angles are congruent. Okay, how about somebody that I haven't picked today? Did anybody? Esther Yoon, have I picked you? No. Can you tell me one of the angles that's congruent to angle 5? Angle 7. Actually, yes. Okay, but what's the most obvious one? Angle 8, right? Because they're vertical angles, right? Would you not agree? And you're right. Kristen, what other angle is congruent to angle 5? Angle 7 is correct, okay? Now, I can see that how angle 8 is congruent to angle 5. But isn't angle 7 congruent to angle 4? So why do you say that angle 7 is congruent to angle 5? You know what I'm talking about? Okay, I can see angle 8 is congruent to 5 because they're vertical angle. We just talked about that, right? But isn't angle 7 congruent to angle 4? But why did you guys say angle 7 is congruent to angle 5? Who could explain this? Brianna, what do you think?
Okay. So since angle 4 and angle 5 are congruent, that means they're all congruent.
Yeah, basically that's exactly right. So actually, since angle 4 and it's because the reason why angle 7 is congruent to angle 5 is because what? Angle 4 is congruent to angle 5. What property are we using here? Let me give you, look, this is what we just said, right? Angle 7 is congruent to angle 4. Oops, sorry. Angle 7 is congruent to angle 4. Angle 4 is angle 4 is congruent to angle 5. That's by given, right? And we also know angle 7 is congruent to angle 5, right? Why? Notice how they put this in this order. Sort of nice. What's the reason? Justin? Transitive property is correct, right? Transitive property of equality or transitive property of congruence? Congruence, because they have congruent symbol, right? Right? So it's because of transitive property of congruence. Let me ask you this. Could we have used substitution for this? How many people say yes? Raise your hand. Very good. How many people say no? You should just use transitive. Oh no, people are not so sure. Okay, like let me see the brave hands of people. How many people say yes? You could use the substitution. You sure? That's how you get it wrong. No, you may not. Because if you do, you get it wrong. Okay, so good for being brave, but now that you know it's wrong, why not? Why can't we use substitution? Because substitution, you can't just substitute this. Oh, one person's here. Why can we not use substitution? Samantha, why not?
Because substitution
That's correct. Remember, substitution is for equalities only, not for congruence. Remember, what does that mean? That means, listen carefully, for substitution, guys, are only used for saying something is equal to another. Substitution is only used for numerical values.
Oh.
It's not for congruence. Please keep that in mind, okay? Does that make sense? But for transitive, it could actually work for numerical values as well as what? Also congruence. Okay, so does that make sense? Let me give you an example why you don't want to use substitution for congruence. Okay, watch this. Give me a sec. Here you are. Take a look at this example. Let's say that I have a segment AB and segment CD intersect. Okay? And here's a picture. And it turns out that segment AB is congruent to segment XY. Is that okay? Now, if you could use substitution for congruence, then watch this. Can we substitute segment XY for segment AB and state that XY intersects CD? No, it doesn't make any sense, right? Do you see why you cannot use substitution, right, for these congruence, right? Then you get a false statements like this, right? XY does not intersect CD. Does that make sense?
Yes.
So this is a nice example of why we shouldn't use substitution, right, as a congruence. Okay, it's only used for equality. Okay, does that make sense? Are we good? All right. Good. Let's do one more example, and that'll be the last one. Okay. Okay, you don't have to write this down, but this is in your book. But let's just do this together. It says, do you guys remember like doing word problems in algebra, how you have to do a 5-step plan and so forth? Okay, so this is sort of similar to that. A supplement of an angle is 3 times as large as a complement of the angles. Okay, find the measure of the angle. Go ahead, I'll give you time. You may talk to your groups to do this, but I want 5-step plan. I want you to declare your variable, right? And express all the other unknowns, right? Come up with an equation and solve. Go ahead, I'll give you time. Go ahead. A lot of you, I think, guys, I like how people are saying x, but when you declare your variable, you have to say what? Let x, not just. How many unknowns do we have? Raise your hand if you think you know. Show me with your fingers. How many unknowns do we have? 1, 2, 3, 4, 5. How many, with your fingers, how many unknowns do we have in this? Not 10. Okay. The answer is not 2. There are 3 unknowns. One of them is what? The measure of the angle that we're looking for. What's the other unknown? Raise your hand if you think you know. Jet, what do you think? 3x? Not quite. What is that? What's that unknown? Not quite. 3x is not the supplement. What's the supplement of this x, Chet? If x is the measure of the x angle, what has to be the supplement of that angle? You're right. Supplement of the angle is one of the unknown. How do you Yes, it's got to be 180. Then 180 minus x is the supplement. Okay. What is the other unknown? Andrew. Complement of the angle, which is 90 minus x. Does that make sense? There are 3 unknowns in this case. Okay. With these unknowns, we may come up with an equation. It says the supplement of the angle. Where's the supplement of the angle, guys? 180 minus x is, what does is mean? Equals to 3 times what? 3 times 90 minus x. That's the equation that you should come up with.
And then just solve for it, right?
Then you solve for it. You know how to. Hopefully you all know how to solve. Guys, who's got the answer for this one? Yes, sir. Shh, I can't hear you. What? It is correct. You get x equals to 45 degrees. Correct? Any questions? Hello, guys. Yes. Hold on. Yes. Yeah. Any questions? Are we good? Can you do something like this for your homework tonight?